This video is about how to evaluate limits, and of course you need to know what a limit is, so we'll address that as well. But this is beginnings of calculus. So a definition of a limit, it's the intended height of a function at a given value for x. The intended height is what you know of as the y value. So you can think of it as what's the y value as the function approaches a certain x value. So the equations you've seen so far in your math career have been pretty continuous, nothing too mysterious about them. But as you get into calculus and higher order equations, things become a little more obscure. So we have what are called limits as to what should the height be there if you're not sure. So let's look at this just for a minute. Here's a graph of a quadratic equation right here, normal old parabola. So the question might ask, what's the limit as x approaches 2 of f of x, which is our quadratic. So as x approaches 2, well, here's where x is 2. Well, what is the height there? Well, what's the limit? What's the intended height of the curve? Well, it's a 4. Okay, so what is it? What's the limit as x approaches 4? So look at this one. What's the limit as x approaches negative 2? So this is coming from the left. Negative 2 is over here. So what is the height of my curve as it gets closer and closer to x equals negative 2? Well, that's right here, isn't it? That is also 4. Okay, but that's because the x is negative 2 over here. So they happen to be the same answer, but they're from two different x perspectives. So graphically, you're looking at what's the y value where the x is whatever. And we'll talk about what happens if there's holes and other things. But if it's just a graph, you just look at it. What is the y value as x approaches a certain value? Now, if you're just looking at equations, there are ways to evaluate your limits with just equations and no graphs. So let's look at that. The first way is to substitute. Plug in x and solve it for y. So really what you're plugging in is what is the limit going to. So in this case, on example 1, x is going to 0. So I'm going to plug in a 0. 0 squared minus 1 over 2 times 0 plus 3 is negative 1 over 0 plus 3 is 3. So my limit is negative 1/3. That's simple. Look at this one. Limit as x approaches 4. Well, plug in a 4. I get 20. So my limit is 20. That's what the y value should be. Limit as x approaches pi. X cosine of x. Well, plug in pi. Pi cosine of pi. Well, look at your unit circle or think about your unit circle. What is the cosine at pi? Well, that cosine is negative 1. So negative 1 times pi is negative pi. That would be my limit. Now this is all fine and good. Substitution works great until you substitute in and you get a 0 over 0 or something undefined. That 0 on the bottom is a problem. You can't have an undefined, so then substitution doesn't work. If that's the case, we go on to method number 2. Method number 2 is simply factoring. Okay, so look at number 4 here. Let's look at why substitution doesn't work for a moment. If I put a 2 in the denominator, I get 2 minus 2, which is 0, which makes this whole thing undefined, which means I can't find a limit, but there is a limit. So I have to use another method, and that's where factoring comes in. So you're going to factor the binomial on top. Hopefully you remember how to factor x and x. This one will factor with negative 4 and negative 2 over x minus 2. And if you recall, this x minus 2 factor repeated will create a hole in the graph, which we'll get more into later, but we did this in rational functions. Those cancel, and what I'm left with is x minus 4. Once I've canceled the like terms, now I go back to substitution. Plug in a 2. So I have 2 minus 4, and the limit itself will be a negative 2. Let's try number 5. Again, if I put in a negative 3 down there, I get a 0 on the bottom. That doesn't work, so I've got to factor. So I'm going to get x plus 3, x minus 2 when I factor it. Cancel the like terms, cancel the whole. So I have x minus 2. When I plug in negative 3, I get negative 5. So my limit as x approaches negative 3 is negative 5. Number 6. Again, if I plug in a 2, I get a 0 or undefined. That doesn't work. So I have to factor. X multiplies to 8 but adds to positive 4. Adds to positive 2, so this is going to be plus 4 and a negative 2. Cancel like terms, so I have x plus 4 left. I plug in a 2, and then I have 6 as my limit. All right, so evaluating. So far we've looked at substitution method and factoring method. There's one more. Okay, this last form of evaluating limits is to rationalize, okay, using what we call conjugates. Back in the day, if you had something like this, you had to multiply by its conjugate, which is the same two terms with an opposite sign between them. And the reason for this is because when you multiply them by box method or FOIL method, what's going to happen is you're going to end up getting those middle two terms canceling each other out and ultimately getting rid of the radicals. That's the goal here, okay? So, for example 7 here, I need to multiply by the conjugate of where the radical is. So this is going to be square root of x plus 4 times the square root of x plus 4. All right? What you do on the top, you got to do to the bottom. So if I FOIL this out, I get x plus 4 square roots of x minus 4 square roots of x minus 16 over x square roots of x plus 4x minus 16 square root of x minus 64. Now, just simplify. These middle two terms on top fall out. So I get x minus 16. Down here, I can combine some like terms. I get 4x, 1x minus 16 square roots of x. So it's negative 15 square roots of x minus 64. Okay, so it's a little nasty, but it works. Now I can substitute in. So I have 4 minus 16 over 4 times 4 is 16 minus, let's see, 15 times the square root of 4. Well, square root of 4 is 2, right? So 2 times 15 is 30 minus 64. All right, so then we crank out these numbers. I get negative 12 on top. Negative 78 on the bottom. Reduce it. Divide both by 2 and you get a 6 over 39. So my limit is this. Okay? Got rid of the radicals, substituted in. Okay? It's a little messy, but you can do it. Number 8 here. Let's do another one. Let's multiply by its conjugates. This one is x plus 1, all into the radical, plus a 1. Again, we're going to FOIL this out. So the x plus 1 comes out of the radical, minus square root of x plus 1 plus x plus 1 minus 1. All of that over x times the square root of x plus 1 plus x. Okay? Middle terms cancel. The 1 minus 1 cancels. So what I have left when I simplify is x over x times the square root of x plus 1 plus 1. Now I'm ready to substitute. So I put in a 3. 3 over 3 times 3 plus 1 is 4. All right, well, 3 square root of 4 is 2. 2 times 3 is 6, plus 1 is 7. So my limit is 3/7. All right, so that's how it works. A few more steps involved, but it's not that bad. All right, I want you to try this one. Figure out what method you need to use. Is it substitution first, then factoring, or conjugation? Which one should it be? Good luck and see you in class.